Okay, business algebra, let's finish up 9.2. This is actually only going to be page 7. Page 8 has more word problems, but they're very similar to number 10 and 11, so we're just going to do one of each to see the difference in wording between combinations and permutations. Okay, so you're like, well, what is a combination? A combination is just selecting a group of R items out of N items total, and you probably think that sounds like a permutation, but a permutation was specifically ordering items. So if you have like an order, first, second, third, and there's differences between being picked first, second, or third, then that would be a permutation. If you're saying that, for example, if I said, the first person I pick gets an $1,000 Starbucks gift card, and the second person I pick gets a $20 Starbucks gift card, you want to be the first person. There's a difference between those two gift cards. If I told you that I'm going to pick 3 people from the class and they're all going to get a $50 Starbucks gift card, then you actually don't care if you're first picked or third picked because you're going to end up with a Starbucks gift card for the same amount. So how do you determine the two of them? If the order makes a difference, you need to use permutation on the problems. If the order doesn't matter, then you use combination. Now, the combination equation is here. It's n factorial divided by r factorial times n minus r factorial. You'll notice that these two were part of the permutation equation, but there's this one extra thing for combinations. That extra thing is there because we have to divide by the number of ways we can pick the same people. For example, if I'm picking 3 people, and we'll call them A, B, and C, and if I pick A, then B, then C, that's a group of 3 people. But if I pick C, then A, then B, that's the same group of 3 people. It's not a new combination, it's just a different order. So even though that different order matters for permutations, it doesn't matter for combinations. Now, the combination equation is really easy to remember if you're going to break it down into these two numbers, because the two numbers in the denominator always add to the number in the numerator. So when we do 10C4, that 10 factorial is still the numerator, 4 goes by itself in the denominator, and then 10 minus 4 is the other number, but 10 minus 4 is just 6. So what do you notice about this? Again, those two numbers in the denominator are exactly the same as added together to the numerator. So this is an easy way to remember how to calculate these if you're not sure what else goes in the denominator, and this ends up being 210. By the way, if you have your calculator, again, in that probability section, this is the NCR button. So if you type 10 NCR4, you should get that same number. And you should be able to find it the exact same way you find the NPR button. Now notice, look at 10 choose 6. If I break it down into its components, that's 10 factorial over 6 factorial times 10 minus 6. But again, this is 10 factorial over 6 factorial and 4 factorial. Something interesting happens here. Look at these two. Are they the same thing? You're like, well, now the numbers are backwards, but yes, they really are the same thing. Why is that? If we had a class of 20 people, and I put you in a group, I said one group of 8 of you is going to get something. At the same time saying 8 of you do get something, I'm putting an entirely different group of people together, the other 12 of you, saying you actually don't get something. So at the same time that I make a group of one size, I'm actually making a group of another size who's not getting something. So in this way, combinations are kind of symmetric about the halfway point. So 10 choose 4, I'm making a group of 4 people that get something and 6 people that don't. It's the same number of groups as 6 people who get something and 4 people who don't. So it's interesting in that way, and it bears out in the equations that they both end up being the same thing. Now 20 choose 8. So I have 20 people I'm choosing from. And remember, we just did 20 with permutations, 8, and it was a huge, billion-dollar number? Or billion number in the billions. 20 choose 8 is still big, but it's not anywhere close to as big. It's only 125,970, which pales in comparison to the 5 billion we had in the last video. So generally speaking, because combinations divide by something extra in their formula, they tend to be smaller than permutations. They're at least always as small. The only exception is with 10p0 and 10c0, choose and permute, are the same thing, because if you're picking none of them, then the order doesn't matter. I mean, there is no order if you're not picking anything at all. And I think 10p1 and 10 choose 1, if you're choosing one, there's a clear order anyway. But otherwise, it should be fine. Now, how does this manifest in word problems? Let's look at the difference in the wording between these two. Out of 12 horses in a show, the top 3 receive money. First gets 1,000, second gets 500, and third gets 100. How many different ways could the prizes be won? So first off, does the order matter? Is there a difference in what you get if you get first, second, and third? Yes. So does order matter? Yes, then you have to use permutation, which means I have 12 horses and I'm ordering 3 of them. Obviously, if you get first, you can't get second. When I do 12p3, I would just put that into the calculator as 12npr3, or you can do it right out as the factorials, but if you do it this way, it ends up being, I believe, 1,320. So there's 1,320 different ways the prizes could be given out. Now, how's that different than 12 horses enter a competition, the top 3 move to the next level? You see this a lot in competitions. You're like, hey, the top 6 runners move on to the next round. How many different 3-horse groups can advance? Well, in this case, does it matter if you're first or third, or are you getting the same thing? You're getting the same thing. You're moving on. There's no reward for getting first. Does the order matter? No. So that means you use a combination. So how do you do this? Instead of 12p3, this is 12c3, and you do 12ncr3, which is a smaller number. It ends up being, I believe, 220. So the more word problems on the last page are just similar situations where you're comparing what the wording in a permutation to a combination would look like. And that is all for 9.2. And we'll do the rest next week.